Hello everyone. So we are going to solve some questions based on NEET chemistry. So first question is the pair of species of oxygen and their magnetic behavior are noted below. Which of the following presents the correct description? So we are given with oxygen atoms. If you see oxygen atom, ions and molecule and molecular ions, and we are given with diamagnetic, paramagnetic. So which of the description matches, right? So first of all, we should know that diamagnetic species is the one which has all its electrons paired, right? All the electrons should be paired. They are called as diamagnetic. And what is paramagnetic? So paramagnetic. So it is exactly opposite of that. Paramagnetic is when the electrons are unpaired, or if any unpaired electron is present, it is called as paramagnetic. So now we have oxygen atoms, molecules and species and its derivatives, right? So we will be using MOT, that is molecular orbital theory. This question belongs to chemical bonding chapter and it's a very important chapter when you consider NEET examination. So we have oxygen species. So using MOT, we know that if you write the MOT, the long form of the you say electronic configuration, you write it like sigma 1s, okay. Then comes anti-bonding orbital, that is sigma star 1s, right? Then comes sigma 2s, then comes sigma star 2s, then comes p orbitals. Okay, from where I'm getting it? So first of all, you should know that oxygen is 1s2, 2s2, 2p4, right? So it has 2p orbital as well. So here we will be writing, first comes the sigma 2pz orbital, then comes sigma, sorry, it's not sigma, it's pi. So I'll just write here pi 2px orbital, then comes pi 2py orbital. Now comes pi anti-bonding orbitals, right? So if you have studied MOT, it will be clear to you. So here we will be having now, first comes pi star 2px, then comes pi star 2py, and then at the last it comes as sigma star 2pz. Each orbital has a capacity to hold 2 electrons over here in the long form. So we have oxygen species, so we just write it here, O2 minus, then we have O2 2 minus, right? Then we have O plus. So for O plus we won't be needing this MOT long form, right? And then we have O2 plus, then we have O2, right? O2 molecule, oxygen molecule. Then we have normal oxygen atom, and then we have O2 2 minus, we have already written. So here what we are going to do is we will find out the number of electrons and then we will fill this long form of the electronic configuration, right? So here we have how many electrons? So we have 8 electrons from one oxygen atom, then 8 electrons from another oxygen atom, plus 1 electron since you have negative charge over here, right? So total we have 17 electrons, right? Here we have 8 plus 8, 8 electrons from each of the oxygen atom, plus we have 2 more electrons since the charge is 2 minus. So total we have 18 electrons for O2 2 minus. For O plus we have 7 electrons. This is because actually oxygen atom consists of 8 electrons, but we have plus 1 charge over here, so we have 7 electrons. Here O2 plus will have 8 plus 8 minus 1, so it will come around 16 minus 1, it is 15 electrons it has. And O2, so here we have 8 plus 8 equals to this color is not visible, equals to 16 electron. Okay, this is not even much not visible. 16 electrons it has. And then we have oxygen atom, just oxygen atom. So I'll write it here. Oxygen atom is 8 electrons, right? So we have written all these species with their number of electrons in it, right? So for O plus and O, we can simply find out if they are paramagnetic or diamagnetic. So in oxygen, you have 1s, 2s and 2p4, right? So you have 1s orbital, you have 2s orbital and you have 2p orbital. So in case of O plus, in which you have 7 electrons here, so you can just fill it 2, 4, then comes 5, 6 and 7. So it consists of 3 unpaired electrons. So very clearly it is a paramagnetic substance, paramagnetic ion, I'm sorry. So I'll just write P over here, right? So just remember it is paramagnetic. Now coming for oxygen, it has 8 electrons. So similarly here 2, 4, 5, 6, 7 and one more electron I put, so 8. Still it has 2 extra unpaired electrons. So this one oxygen atom is also paramagnetic in nature. Let's check for O2 minus, O2 2 minus, O2 plus and O2. So it consists of 17 electrons. Let's fill the electrons. So 2, 4, 5, 6, 7, 8, 9, 10. Now here pi 2px and pi 2py, they lie at the same level. So if you have learned this, you must know this, right? So how many electrons we filled? 2, 4, 5, 6, 7, 8, 9, 10, 11 and then 12, right? Then 13, then 14, right? And then comes 15 and then comes 16 and then comes 17. So yes, in pi star 2py we have one extra electron which makes it paramagnetic. Now coming to O2 2 minus, so basically it has one extra electron. So basically this will be filled and it will become 2. So all the electrons are paired. This one is diamagnetic. Now coming to O2 plus, which has 15 electrons. So here I have filled 18 electrons. So I'll just remove few electrons from here. Yeah, I'll just make it 15. So let's make it 15. So we have 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay, 13, 14, then comes 1, 15. So again it has one extra electron, so it is also paramagnetic in nature. So we got which of among the following are diamagnetic and which are paramagnetic. We will check now. O2 minus and O2 2 minus, both diamagnetic. Is it true? So no, it is not true. O2 minus is paramagnetic. Okay, so this is not the answer. Then O plus, yeah, it is paramagnetic. Then O2 2 minus, O2 2 minus is not paramagnetic. So this is also not the answer. Then comes O2 plus. Check for O2 plus. It is paramagnetic. I forgot to write. Sorry, it should be here. Yeah. So it is paramagnetic. And O2, where is O2? 16 electrons. I forgot to put it. So if you put the 16 electron, the next electron comes here. Again, it is also paramagnetic. Yeah. So both of them are paramagnetic, right? So option C is correct. Check for the D. O, just O, it is paramagnetic. Okay, fine. O2 minus, O2 2 minus, it is diamagnetic. So this one is wrong because O2 2 minus is diamagnetic. So here we got our answer. Option number C is the correct answer. Now coming for the second question, right? The number of Cl minus ions in 100 ml of 0.001 molar HCl solution. So this question belongs to first chapter of class 11, that is some basic concepts of chemistry. And this is basically, it is concerned with molarities concept, that is concentrations unit, right? So the number of Cl minus ions we have to find out. We are given with HCl solution, and HCl is a strong electrolyte. In the solution, it will dissociate as H plus and Cl minus ions, right? So from here we get to know that 1 mole of HCl gives you 1 mole of H plus ion and 1 mole of Cl minus. So what we can do is we can just simply find out how many moles of HCl ions are there in this given concentration, right? So we are given with the molarity and we have the volume. So we know the molarity is equals to number of moles upon volume, that should be in liters, right? Molarity is given to us as 0.001 equals to number of moles we have to find out. I'll just write it as N, volume in liter, so 100 ml we have. When you convert it into liter, it will become 0.1 liter, right? So from here we get to know that number of moles of HCl are how many? It will come as 0.0001 moles, right? So here we get to know that if 1 mole of HCl gives 1 mole of Cl minus ion, so definitely 0.0001 mole will give 0.0001 mole of Cl minus ion. But is it asked? No. The number of molecules are asked, right? So we know the standard that 1 mole consists of 6.022 into 10 to the power 23 molecules. So I hope you know this. This is the standard relation, right? So how many moles consist of, or if you consider the ions, let's consider ions. So 1 mole of Cl minus consists of 6.022 into 10 to the power 23 ions, right? So 0.0001 mole consists of how many ions? So we will do the cross multiplication and we will get the answer as 6.022 into 10 to the power. So if we have 1, 2, 3, 4, we have to reduce 4 from here. It comes as 19 ions, right? So is it any option matching with it? So let's check. Yes, option number C matches with the second question. So this question is also clear. I hope you understood it. So let's move ahead with the third question. So third question is, the following solution were prepared by dissolving 10 gram of glucose. This is the formula of glucose in 250 ml of water, and P1 is the pressure given. So we got to know that we have glucose C6H12O6. So this is a simple trick. You keep writing things when you are reading the question. It makes your it saves your time and it makes the question easier for you, because now the proper data form is in front of you when you write it, right? So what you have done, 10 gram of glucose dissolved in 250 ml water, right? And its pressure is P1, right? Vapor pressure is P1. Now we have 10 gram of urea. So we have CH4N2O, and this is also 10 grams, which is again dissolved in 250 ml of water, and the vapor pressure is P2. Coming for the third one, it is sucrose C12H22O11. It is also 10 grams, same conditions, okay, and dissolved in 250 ml water, and the pressure given is P3, right? The decreasing order of osmotic pressure of these solution is. So this particular question, it belongs to the second chapter of class 12, that is solution, and in that you have colligative property, osmotic pressure. So we know the formula of osmotic pressure is P pressure, that is osmotic pressure, is equals to ICRT, right? We have ICRT. So I over here, you don't have any value of I is the Van't Hoff factor. It is required when you have ionic solution. So here all of them are covalent compounds, so you don't need I over here. The value of I for all of them is 1. Now concentration, does it differ? 10 gram, 10 gram, 10 gram. Do you think it will differ? Yes, it will. Why so? This is because the molar mass of all of them are different. R is the gas constant and T is the temperature. So it remains constant for all of them, right? So this concentration will decide which will be having the highest osmotic pressure, which will be having the lowest osmotic pressure, right? So I will just erase this. Yeah, and do you know how to find out the concentration? Concentration is equals to, basically this is the molarity which you have to find out. So this is number of moles upon volume, right? Volume is same for all of them, so we won't be considering volume. Number of moles will differ. Now how you calculate number of moles? Number of moles are calculated as given mass which is again same for all of them, 10 grams upon molar mass. So molar mass will differ for all of them. So I'll just write the molar mass over here, right? So simply on the basis of molar mass, so over here I'll just write molar mass over here, M1 I will write for it, for glucose. So it is 180 gram. I hope you know how to calculate the molar mass. You just need to add the atomic masses of all the atoms present in the compound and you will get the molar mass. M2 I'll write here. So M2 for urea, it is 60 grams, and M3 for sucrose, it is around 342 gram. If you calculate 12 into 12 plus 22 plus 11 into 6, this is how you do it. I hope you know it. They teach you in grade 9 only, right? So we have different molar masses. So P1 pressure, so number of moles, whichever is having the highest number of moles have the highest pressure, right? So for P1, which is for glucose, so I'll just ignore I, since I is 1 for all of them, all of them. So concentration is 10 upon 180 and whole upon 250 RT, right? P2, that is pressure of urea, it is 10 upon 60 whole upon 250 RT, and P3 is equals to 10 upon 342 upon 250 RT. Now answer is in front of you, don't need to do anything, right? You can easily guess it. If the denominator is higher, the value of the whole term or the number of moles will be lowest. So P3 will be the lowest. This is because this whole thing, the number of moles things will be lowest for sucrose, right? Then P3, after P3 you have P2, and then you have, sorry, after P3 you have P1 and then you have P2, right? So P2 will be having the highest pressure, and after that you will have P1 and then comes P3. So this is the answer. It matches with the option number C. So option number C is our answer. So I hope you understood this. Let's move ahead for the next question. Aniline is weaker base than ethylamine. This is due to, so this question is from organic chemistry, and organic chemistry is approximately 34% of your NEET examination. So what is aniline? So aniline is benzene ring with NH2. This is aniline, right? Aniline, right? It says that aniline is weaker base than ethylamine. Ethylamine is CH3, CH2, NH2. How do I know it? This is because this is ethyl group, CH3, CH2, and amine, sorry, it is CH2, I'm so sorry, it is CH2, and this is amine group, right? It says that it is stronger base and this is a weak base, right? It says it's a weak base. So what is a base? A base is the substance which can easily give its electron, right? So nitrogen has a lone pair, okay, which makes it as base, or whole ammonia is acts as a base. This is because of the lone pair on the nitrogen atom. So over here, these lone pair which are there, they will involve in the resonance of this whole ring. Okay, so this will get occupied, you know, all you draw these structures like this. So I'll draw a few for you. So you have NH3. So these electrons will be involved in the resonance of the aromatic ring. This bond will shift here and you will get a resonance structure, that is negative charge here, double bond with NH2. So this is NH2 with a positive charge over here, and you have this. So in this way it keeps going on, and these lone pair will get involved into the resonance of aniline, whereas for the ethylamine, here you don't have to worry about the resonance. These electrons can be easily donated, right? And when the electrons are easily donated, it makes it a stronger base. Now this effect, what do you call this effect as? So this effect is called as plus R effect. This is because plus R means, it means that it is in the resonance. Okay, this electrons are, NH2 is a group which is donating its electron, it is giving its electron. Okay, and which is plus R effect. Plus means it is giving, minus means it is taking. It is a electron donating group. Okay, if it is minus R, it is electron taking group or withdrawing group, right? So ammonia is a electron donating group. It will donate the electrons, and these electrons will involve in the resonance, which is plus R effect of aromatic ring. So here, do you have any option like that? Yes, plus R effect of NH2 in aniline. So D option is the correct answer. Now moving ahead for the fifth question. The coordination number and oxidation state of X in the compound, this thing. Okay, so this is the question from coordination compound, a very, very important chapter. You can say it consists of 7% of your NEET examination question paper. Okay, so here it is asking coordination number and oxidation state. So first of all, we need to be very much clear with these two terms. Okay, so coordination number is the number. So you have X, it is the number in which how many species are surrounding X. Okay, or they are directly touching the X, right? This is called as coordination number, whereas oxidation state is the formal charge or overall charge which is there or which is possessed by that species. So if you see this, it is X, SO4, that is sulfate, NH3, okay, and this is 5, right? So here, do you know SO4, that is sulfate, it possesses -2 charge, and ammonia, NH3, it doesn't have any charge, right? It doesn't have any charge, so you call it as 0 charge. Okay, and overall on here you don't have any charge, so it is 0 charge overall the entity. So X, let us consider the charge on X as small x. Sulfate has a charge of -2. This doesn't have any charge, so I'll just write 0, and at the end you don't have any charge on the entity as well. The overall complex, you don't have any charge, so I'll just write 0 here. So from here we get to know that X is equals to +2, right? So from here we got to know that oxidation state or oxidation number is +2 for X, right? And the coordination number, the number of species which are surrounding this X is the coordination number. So you have 5 ammonia and 1 sulfate. So total we know that coordination number of X is equals to 6. So do we have any option like that? Coordination number 6, yes, and oxidation state as 2, yes. So we have option number C as the correct answer. So I hope I have cleared your doubt on this question. Thank you.